Hello there, and today I'm going to be working through a vectors question from the Edexcel M1 paper in June 2011. This is question 7 of that paper. What I'm going to do is I'm going to work through each part, and after each part I'm going to explain where the marks are allocated. And just like all vectors questions really, I and j are unit vectors going due east, so you can think of that as a positive x-axis, and due north, which is like a positive y-axis, and the position vector given relative to fixed origin O. So what we're going to do is we're going to start by looking at this question. Two ships P and Q are moving with constant velocities. So ship P has velocity 2i minus 3j, and ship Q moves with velocity 3i plus 4j. And for part A, for 2 marks, it says find to the nearest degree the bearing on which Q is moving. So if we were to look at ship Q, the velocity of ship Q is 3i plus 4j. If we were to draw that vector from any given point, then we would go along 3i and we would go up 4j. So my vector for the velocity will go something like this. Now, if my ship Q is travelling along this line, then you need to be able to recognise that from this origin here, with the north line here, the bearing will be measured from north to the velocity. And what I'm going to do to start with is I'm going to find this angle here, which I'm going to call theta. So using trigonometry, I know that tan theta is equal to opposite over adjacent. This is 4 and this is 3, so it's going to be tan is opposite of 4 divided by 3, and rearranging that tells me that theta is equal to 53.13 degrees. Now that's this angle theta inside the triangle. That's the angle that the velocity makes with the positive I direction. That does not make it the bearing. Remember, I want the angle measured from north. So because this is a right angle, to find this angle, this bearing measured from north, I'm going to take my value of theta away from 90. So in 90, take away 53.13, that gives me 36.87. So my bearing, remember we want this as a 3-figure bearing, would be 0. I'm just going to round it to the nearest whole number, so 0, 3, 7 degrees, and that is this angle here from north down to the vector. Now where these marks, this is a 2-mark question, where marks are allocated here, you get 1 method mark for using trigonometry to find either this angle straight away or the angle theta, and you get an accuracy mark for if you find this angle theta first, then to get the method mark you have to know that you are going to take this angle from 90 as well. And the final mark for the second mark is just an accuracy mark, which is getting the correct answer. So moving on, question 2 now says, at 2 p.m. ship P has a position vector of point I plus j, and ship Q has position vector minus 2j. And at time t hours after 2, the position vector of P is just a bold P, so we can write P underlined, and the position vector of Q is a lowercase bold q underlined. And we have to find expressions in terms of t for these 3 vectors. Now this P, that is the position vector, the general position vector of P, dependent on time. And the way we're going to write this out is using a well-known formula, or hopefully a well-known formula in Mechanics 1 vectors, which is R equals R0 plus VT. What that means is the general position vector dependent on time at any given time for a point is equal to its initial velocity vector, initial position vector plus its velocity vector times time. So for P, the initial position when time, at 2 p.m. is I plus j. So for R0 I'm going to substitute I plus j, and then the velocity, it told us in the previous question, P is moving with velocity 2I minus 3j. So if I substitute that into this formula, I will get plus t times 2I minus 3j. Now doing exactly this, that's part 1. Doing exactly the same thing for part 2. For q, its initial position vector at 2 p.m. is minus 2j. And then we're going to add on time. This is a variable, it could be any number, depending on what value, depending on what number we substitute for time, obviously affects what position vector q is at. So we're going to put time and times it by the velocity. And again, from part A, we know that the velocity of q is 3I plus 4j. So substituting that in to this formula again, we're going to have t plus 3I plus 4j. And what we have here is we have two expressions, one for the position vector of p, one for the position vector of q. Both of them depend on t, and both of them come from this formula here, r equals r0 plus vt. Now, for the third part, we have to find a general expression in terms of t for the vector pq. Now, to do that, I'm just going to draw a very simple diagram. I'm just going to say, imagine my ship P is at this point. So if the origin is down here, then the vector P is along here, to go from the origin to the ship P. And if my ship Q is at this point, then we will have to go along this vector, which is Q underlined, to get from the origin to Q. And PQ is obviously the vector for how we get from P to Q. So that there is P to Q. Now to get from P to Q, we're going to go back down P, underlined, that vector, and then along Q. So from P to Q, that path is the same as minus P plus Q, which is the same as Q minus P. Now, in part 1 and 2 of this question, we found an expression for P and Q, the position vector of each of these. So what I'm going to do is I'm going to substitute both of these into my expression for PQ. So for Q, I'm going to do Q take away P. So Q is equal to minus 2j plus T times 3I plus 4j. I'm going to take away my expression for P, which is taking away I plus j, and then taking away T times 2I minus 3j. Now, if you were to expand and simplify all of this, then you would get minus 2j plus 3ti plus 4jt minus I minus j minus 2ti, and then minus and minus will give me plus 3tj. Now collecting these like terms will give me minus I will have minus 2j, take away j is minus 3j, and then I will have 3ti take away 2ti is plus ti, and 4jt plus 3tj, that is plus 7jt. And if I was to factorise that, that would give me minus I, that would give me minus I, not plus, minus 3j plus t times I plus 7j. And that there is my general expression involving t for the vector p to q. Now how the marks are allocated for this part, you get one method mark for correctly using this formula. So for knowing that you're going to use R equals R0 plus VT, and you get an accuracy mark for each of the final answers for P and Q. And then for part 3, you get a method mark for knowing that to find the vector P to Q, you have to do lowercase q take away lowercase p, and then substituting in all these values for Q and P that we have already found, expanding, rearranging and simplifying, getting this final answer, that is your final accuracy mark. So that is where the 5 marks for part B of the question are allocated. Now part C, a lot of students may find fairly tricky. Okay, but the good thing about part C is, although it's tricky, it's only worth 4 marks. So you have to do a lot of work to get these 4 marks, but at the same time, if you struggle with understanding this concept, it's not that many marks that you're going to lose on the paper. Now what it says is, find the time when part 1, Q is due north of P. Now for Q to be due north of P, that means to go from P to Q, so starting at P, going to Q, that will be going straight up. So that will be equal to some vector, lambda j. Essentially, lambda is just a constant, and I know that because it's due north, it's straight up, then that has to be equal to some constant times j. In other words, we can't have any I component of this vector, because that would mean that the vector is going slightly to the left or slightly to the right, which obviously would not be due north. So what I'm going to do is I'm going to take my expression from part B, part 3, down here. That's my expression for PQ, and I'm going to set that equal to lambda j. So if I do that, I will get minus I minus 3j plus t times I plus 7j is equal to lambda j. And remember, this is basically saying that the I component of the vector must be equal to 0. So what I can do in this case is, because I know that the I component is equal to 0, then this minus I plus ti must cancel out, it must disappear. So if I was to equate the I component of this equation, then I would get minus 1 for I plus t is equal to 0 I on the right hand side. And rearranging this tells me that t equals 1. So at t equals 1, the vector pq must have the form lambda j, which means to get from p to q is just a vector depending on j, so it must, therefore q must be due north of p. Carrying on for part 2, we're going to do a similar thing, except it's slightly trickier now. Q is northwest of P. So if we were to look, if Q is northwest of P, so P is here, and we're going along this vector to get to Q, this is northwest, then we would be going along minus I and up j. So we're going back 1 and up 1 for every step, and that would give me a perfect northwestern bearing. So this angle here would be 45 degrees. So using a similar argument as part 1, I'm going to take my general expression for PQ, and instead of saying that is equal to lambda times j, I'm going to say, because it must be parallel to the vector minus I plus j, I'm going to set it equal to lambda times this. So my expression for P to Q is minus I minus 3j plus t lots of I plus 7j. Now because this has to be parallel to this vector in order for Q to be northwest of P, I'm going to set this equal to lambda times minus I plus j. Okay. Now this is an equation. It is a vector equation, so it has I and j components, and there's 2 unknowns. There's t, which we want to find the value of time when this is true, and there's this constant lambda. So what I'm going to do is I'm going to equate separately. I'm going to equate for the I component, and I'm going to equate for the j component. So equating the I component, I have minus 1 plus t equals minus lambda. And then equating the j component, I have minus 3 plus 7, plus 7t, sorry, because that's plus 7tj. That must be equal to plus lambda. So I'm going to label these two simultaneous equations 1 and 2. Now remember, it's the value of time that we're looking for here. It's not the value of lambda. So I can actually eliminate lambda straight away by adding these two simultaneous equations. If I was to add equation 1 with equation 2, then the minus lambda and the positive lambda will cancel out. And what I will get is I will get minus 1, adding minus 3 gives me minus 4, plus t plus 7t, that is plus 8t, and on the right hand side, minus lambda plus lambda equals 0. And rearranging this tells me that 8t is equal to 4, so t is a half. So when t is equal to half, the vector p to q is parallel to minus I plus j. And that is the vector that is needed for q to be northwest of p. Now, for where the marks here are allocated, you would get one method mark for setting your previous value of pq equal to lambda j. So now that is what it takes to parallel to the vector j, in other words, for q to be due north of p. And finding the exact answer for time is a second mark, that's your accuracy mark. And then similarly, on part 2, equating the vector pq equal to lambda times minus I plus j, that is a method mark. And then for all of this hard work here, which can be fairly tricky to understand, and it can be easy to make a mistake, there is one accuracy mark. Okay? So if you don't understand this, if you do understand this, it's quite a lot of work for one mark, but at the same time, if you're not too confident on this specific topic in vectors, it is only 1 or maybe 2 marks that you would be losing. So that was June 2011 question 7 from the Edexcel Mechanics 1 paper. Thanks for watching, and I hope to see you sometime soon.